period 3, we're looking at 15 as it relates to the lab. Oh, you know what? I'm going to graph it by hand. I was going to graph it on the graphing calculator, but I don't know how to do piecewise graphs. 7, if you look at it, really is a piecewise graph if you tried to write it in terms of the pieces. It has an absolute value in it, correct? That means it's a piecewise graph. So let's try to graph this thing. And we should know what it looks like, because I think this is going to help you see what's happening here. First up, is it continuous? Because if there's a break in the graph, how can you find a tangent line? Like if you had something like this. How can you find a tangent line at this point? Which side are you going to use? Doesn't make sense to me. So for you to be able to find a tangent line, it's got to be continuous. So is this function continuous? Well, let's find out. How do you know if it's continuous? First, now this is at 0. So what's f of 0? Which formula am I going to use? First one or second one? Nope. This is including the 0. So it's 2 times 0 plus 2. So that's 2. If it's continuous, the limit from the left has to equal the limit from the right. Well, this is a polynomial. The limit at 0 is 2. I mean, that's not going to be a problem. But I need to check this limit, because that's a totally different function. As x goes to 0, of 2 minus 2x minus x squared. What's that equal to? 2. Okay, girls? Later. So at 0, these do match up. They match up at 2. Now let's do the easy one first. What's the graph of 2x plus 2 look like? This is nothing new. What's the graph of 2x plus 2? It looks like a line. So I'm going to graph a line there with a slope of 2. So it looks like this. What does the other side look like? Without even, without doing any work. It's a parabola. What kind of parabola is it? It's upside down. So it might be in our best interest to find f of negative 1, just to see where we're at on our parabola. So that's equal to 2 minus 2 times negative 1 minus a negative 1 squared. So that's equal to 2 plus 2, and this minus 1 squared is positive 1, but then I'm going to subtract it. So where am I? 3. So at negative 1, I'm up at 3, because I really don't care what happens with the parabola after this. My guess is it does this, something like this. Who cares? All I care about is right there. And that looks kind of like question 7 on the left, doesn't it? Yeah. How can you draw a tangent line here? What would have to be true about the slope on the left side and the slope on the right side? They'd have to be the same, because remember, a slope is a limit. So when the limit coming from the left, it's got to be equal to the limit coming to the right. Not of the function, the limiting value of the slopes has to be the same. So there is no tangent line here. Now, could I actually prove it? What is the slope on the right side of 0?
2x.
So I can actually, not 2x, slope is always a number, so I could write a little piecewise graph for x less than or equal to, x greater than or equal to 0, the slope was 2. How am I going to find the slope for the other one? I have to use some calculus to find the slope for that. And some of you are going to say, oh, that's too hard. It's not bad, actually, because we did it in the other class. Actually, this one is easy. F of x is equal to 2 minus 2x minus x squared. Okay. So let's find it. How do you find the slope of the tangent line? Remember? Here's the C. You could. Okay. There's C plus H. What's this ordered pair? F of C. And this is C plus H, F of C plus H. You have to get away from the memorizing, because it's too hard. So the slope is equal to the limit. I want the distance between these 2 points, H, to get smaller and smaller. Because I'm taking this point right here, and if I drag it down the curve, what's true about the distance between the 2 points? because that's what h is, going to 0, right? Okay. So it's going to be this y value, f of c plus h, minus f of c, all over c plus h minus c. What happens to the c's in the denominator? They cancel. So we've kind of, this you might want to memorize, but it's, I'm not even memorizing. I figure it out. It's just slope. If you realize it's just slope, it's easy. Otherwise, it's not so easy. Okay, we'll take a baby step here. What's our c value going to be? That's what makes this easy. Where am I finding the slope?
0.
At 0. So m, maybe I better change colors, or maybe slide down. So my slope is going to be equal to the limit as h goes to 0, and I want f of 0 plus h minus f of 0, all over h. Okay, so now I'm going to substitute in 0 plus h for my x's. Are we okay with that? If not, you need to come see me. M equals
0 something.
What is? I'm going to substitute 0 plus h right in there for my x's. That's function notation.
We got 0 from
Because we're doing this, where's the only place I got issues? A parabola is fine.
0.
It's at 0. It's where they join. Now, if they didn't even connect there, then we wouldn't even be able to, we'd be done. It's not continuous. How you can find a tangent line when there's a break in the graph? Think about that. Doesn't make sense. Okay, so I'm going to put this in. It's 2 minus 2. It's 0 plus h minus 0 plus h squared. That's the first one. Then minus f of 0. What's f of 0? Put 0 in here. It's what? 2. It's just the ordered pair. We already knew that, right? We knew this one through 0, 2. I always have to hesitate because I get my x's and y's reversed. All over h. Some of you just want to do the numerator and then come back and put the h in later. You'll get marked off on the exam, on the AP exam. Can't do it. It's mathematically not correct. The other issue is when you get into engineering, into some of those upper level classes where you're problem solving, this is simple compared to what you'll be doing, and if you start doing that, you will get lost. My pre-algebra students get lost because they will not show the work on just simple order of operations. That's the reason why they're there. If they would show the steps, then it tells you what to do. This tells me what to do. Can't cancel those h's, you guys. So m is equal to the limit as h goes to 0, and this is going to be 2 minus what? 2h minus h squared minus 2. So it wasn't so bad, was it? It's actually one of the easier ones. I have to distribute my negative with along this, with this 2.
So 0 plus h squared.
0 plus h squared is just h squared. Because h plus 0 is just h. What happens to 2's? They go away. Why can I do this so fast? Because I've done this hundreds of times. Okay, thousands of times.
H.
So, I get negative 2h minus h squared all over h. And I personally just divide it, but we'll go ahead and factor it. Notice how I keep my limit throughout the whole problem, because it's like adding and throwing out the plus sign. Can't do that. Doesn't make sense. Did I factor that correctly? I think I did.
Take a negative h out.
I'd rather just take out h because it's complicated when I do negatives. Because h goes to 0, so that's going to be 0. So what's the slope equal to? Negative 2. Look at my picture. Does that seem reasonable? Yes, it does. Looks like a nice little V there. So,
0.
at x less than 0. So, does that make sense that you cannot change abruptly on your slopes? It's the same as if you're in reverse on your car and you do not stop and you just shift it into drive. That would be really bad. It's the same thing because this is a velocity. You have to stop. Okay. So, did that answer your question on 7b? I really should have, because what's happening here, we have what they call a what? It's coming down, it's curving in here, and it's, you either can call it a sharp corner or a cusp. Anytime it comes in at a cusp like that, can you draw a single line to represent this slope and that slope? Can't do it, can you? You'd need two. You can only have one.
I'm just confused because in 7B there's like absolute value signs in it.
Graph it. You don't have to do it algebraically.
Oh, I know.
It's a graph. 7B is just a graph. And you're looking at pictures like this. And you should be able to transfer, hopefully, what I just did here. You don't have to do all this stuff. And then we have some physics problems in the second half of the assignment. So I could do this video a little differently. We did 23. We could do 23, 27, similar. And then when you do the true-false questions, you better be able to justify your answer. In other words, write something down. Same thing with the multiple choice ones. Some of those are tricky. Let's do 23, or we could do 27. I don't really care. 23's, they're both about the same. Do you know how to do the physics problems? Notice tower on 23. See if I draw a better picture. It's not great. And the tower is 100 feet above the ground. And you're going to drop an object. So when you start here and you drop this, what is your initial velocity? Zero, because you're not throwing it. You're not giving it a velocity, you're just going to let it go. So at the second I let it go, its velocity is zero. A couple seconds later, it's not going to be. And so the position equation is 100 minus 4.9 t squared. No, I haven't memorized that. I know the formula from physics that your position's 1/2 at squared plus the initial velocity times time plus the initial height. From physics. Anybody's in physics, you might remember it. The physics formulas start to make sense. And the question is, how fast is it going when t is equal to 2 seconds? Is it meters or... Are we in meters or are we in... I don't even remember.
It's 4.9.
Oh, it's meters.
You get to 4.9.
That's the constant due to gravity. It's 1/2 the gravity. You don't have to worry. They give you the formula.
From that 1/2.
Yeah. Oh, yeah.
It's 1/2 of at squared, where a is equal to 9.8 meters per second squared.
Yeah.
Okay. I don't want to know where it is at 2 seconds. I want to know its speed. So how do you find speed? In this case, it's velocity. It should be negative because you're going down. But the speed is the change in your position divided by the change in your time. If you don't know that, then you shouldn't be driving a car because it's miles per hour. If you drive 55 miles per hour, in 1 hour you will have covered 55 miles. Now what about those race car drivers? How fast are they driving?
NASCAR.
They're going 250 miles per hour. So in 1 hour, they go 250 miles. That's halfway to Chicago in an hour. You get to Chicago in 2 hours. That'd be amazing. Okay, that's really fast. So that's what we're talking about. Speed, your velocity, is how fast you're moving. So guess what I have to find here? I have to find this. So the slope, or the speed, velocity I'd rather call it, actually, is the limit as h goes to 0, and it's going to be s of, in this case, it's 2 plus h, minus s of 2, all over h. I want to find the the instantaneous velocity at that point. Now, do you need me to do the math, the arithmetic? Sorry, algebra? Yes, no? This is your velocity. We'll see more of it. Think of some of these problems as really being an introduction to what we're doing. Do you need me to do that?
No, it's just 2s minus 2s. Plus,
No, it isn't. You can't go 2s plus hs.
you multiply it through, it's 2s.
No. That's function notation. You actually have to substitute this into my little formula, which is 100 minus 4.9, 2 plus h squared, minus S of 2, which is 100 minus 4.9 times 4. Sorry. All over H. So yes, you do need me to do the math.
You can't multiply it on the very top, go S, 2S.
No, it isn't 2S, it's function notation. It's F of.
Oh, well,
So I start over here this time. I might not run out of space. So it's 100 minus 4.9, and then I got to square that, which is 4 plus 4h plus h squared. And I don't like doing arithmetic, so notice what I'm going to do. Now, this is minus 100 plus 4.9 times 4, all over h. I'm going to have to do some of the arithmetic, but not a lot. Okay, ready? So I want to simplify that numerator. This is a parentheses, basically. It says, do what's in the numerator. You're going to see nice things. It's 100 minus 4.9 times 4. There's parentheses. Minus 4.9 times 4h. Minus 4.9 h squared. Minus 100 plus 4.9 times 4. Things are going to go away. Okay, so what goes away? 100. What about the 4.9 times 4? Yes. Okay, I'm still going to have to do 4.9 times 4. We're going to do it without a calculator because we can. I'll show you how.
19.6.
It's minus 4.9 times 4h minus 4.9h squared all over h. Did you use a calculator or did you just...
No, it's 9.8 times 2.
Oh, okay. That's another way to do it. Otherwise, I was going to take 5 times 4, which is 20. And I'm off a tenth. So 4 times a tenth is 4 tenths. Take 20 minus 4 tenths, you get 16. 20 minus 4 tenths, 19.6. I'm awake. Okay, let's factor out the h. Negative 4.9 times 4 minus 4.9 h all over h. And so it's, and you don't even have to multiply it out. I don't care. So this is really 5 minus 0.1 times 4. I just distribute. It's 20 minus 0.4, 19.6. Just a little math trick.
Wait, how'd you get the 5?
4.9 is 5 minus 0.1, right?
Yeah.
So 5 times 4 is 20. 4 times 0.1 is 0.4.
Oh, you're just saying.
I'm just doing another way. But what you did was
Yeah,
4.9 times 2 times 2, and you said from physics I know that's 9.8, and I can double that fairly easily. Doesn't matter.
Yeah, I keep going with the problem.
That's it. That's it. What's the speed? Negative 19.6 meters per second. You have to do a derivative. You can't evaluate S of 2. That's the position. To find the velocity, you have to do a derivative.
Is it bad that this is that I don't really
The what?
I just don't really get it.
Because you know the physics equations. Yes, you have to figure that out because the minute we're not into a constant acceleration, now you're in trouble. You have to do some calculus. And so 27 is the same thing. It's actually easier numerically. And 19 is the same thing. That's why you need to practice. Well, it's kind of blank. I mean, just look at the answers. They're all using that F of C plus H. If you do this, you'll be able to do it just faster and faster.
Then I looked at it.
You don't want to do it.
Old.
Well, how do you get better at algebra? Why do you think I'm good at algebra?
She does it a lot. You're naturally gifted at that.
No, at the end of 6th grade, I had to be tutored in math because I didn't know my skill stuff. I didn't know my multiplication tables. I didn't know any of that. And then 7th grade, I got C's in math because it was kind of boring. Although we were watching Herman Killebrew and Tony Oliva. You guys even know who those guys are?
Yeah.
Of course.
Watching them, and my math teacher said, Tony Oliva, he's just a flash in the pan. She was wrong, obviously. Yeah, those were great baseball years. So we did that. That was kind of boring. Then I got to algebra, and I go, I like this. I love doing algebra because it makes sense. Just do what it says. It tells you what to do. That's what's cool about math. Oh, I got an email. Where's my recorder?